Welcome to another lecture of Design Principles of Concrete Structures. In this lecture, I will discuss how to transfer the load from slabs to beams. Okay, this is the title of the lecture, Load Transfer from Slabs to Beams. Before discussing the load transfer, first of all, I will discuss briefly one-way and two-way slab. Here is the one-way and two-way slab. This is the length Ly, this is the length is Lx. The ratio of these two lengths Ly longer to shorter, if longer to shorter ratio of the slab, this is a slab supported by beams, okay, first beam, second, third and fourth. If the slab supported by beams having the ratio of Ly over Lx greater than 2, then that slab is one-way slab. And if any slab the longer dimension to shorter dimension ratio is less than or equal to 2, then that slab is two-way slab. Okay, let's see the examples. First of all, one-way slab. Here is the one-way slab. Okay, this is the longer side. Okay, this is the shorter side. This longer side to shorter side ratio is greater than 2, so this slab is one-way slab. And you can see the whole of the movement is lie on this region. Okay, bending is in this region. So for the transfer of load, we consider the half load will be transferred to the right side and half load will be transferred to the left side on the beam. Means whole slab load will be transferred in such a way that the half slab load will be transferred to the right beam and the half slab load will be transferred to the left beam. Okay, the minor load also transferred to the edges by we ignore in the one-way slab. We for the transfer of loads, we simply cut the slabs into two parts and transfer the half load on the right beam and transfer the left half load to the left beam. More examples of one-way slab. This is the continuous one-way slab. First one-way slab, second, third and fourth. This is the continuous. Similarly, for this beam, half load will come from this slab, half load will come from this slab. Okay, and for this exterior beam, only half load will come on this beam. Okay, this is the one-way slab distribution. This is again the view of the one-way slab. Again another view of one-way slab. Okay, so now let's see the two-way slab. This is the isolated means single two-way slab. In the two-way slab, the load transfer on all sides, means on all four beams. Okay, you can see the distribution. Okay, the distribution is just like homogeneous or will transfer to all beams. Again come back. Okay, in the two-way slabs the load transfer will be to the all four sides of the beams. Okay, in the one-way slab only load transfer will be on the upper side and the lower side. Okay, means on the longer direction. Again, this is the simple plan of any building. Okay, here you see the beams, here interior beam, and again there is small beam, okay, which is resting on these beams. In the slabs configuration or the slab identification, we see the slab supported by elements. Now you can see this slab is supported by four beams, and again this slab is supported by four beams, and this slab, whole slab, is supported by four beams. Okay, this beam, this longer beam, this beam. Okay, so in this plan of the building there are three slabs, 1 2 3. We will check one by one. For example, here 4 meter and 2 meter. Okay, 4 divided by 2 is 2, so that is again two-way slab. If the longer to shorter ratio is less than or equal to 2, so that is two-way slab. This slab is again two-way. 4 meter longer span, 2 meter shorter span, 4 by 2 is equal to 2, again two-way slab. Let's see this slab. 4 meter is this length, and this length is also 4 meter. 4 meter by 4 meter is equal to 1, again less than or equal to 2, so that is a two-way slab. Okay, now by definition, beam supporting one-way slab. If longer to shorter span ratio is greater than 2, so then that slab is called one-way slab. Okay, so first of all, let's see the configuration. Here is a beam, exterior beam, again exterior beam. Okay, here is the exterior shorter beam, again shorter beam, and here is interior beam also present at the inside of the slab. Okay, means these are the column arrangements. Now this is first beam, interior beam, exterior beam. Okay, so now how many slabs are present in this configuration? Here is first slab, here is second slab. Okay, so longer span, here is the longer dimension, here is the shorter dimension of this slab. Okay, I have already discussed that we consider the slab which is supported by elements. Now this slab is supported by 4 elements, this long, short, long, short. Okay, so this dimension is Ly and this shorter dimension is Lx. So Ly over Lx is greater than 2, so that's why this is the one-way slab. And for the load transfer mechanism on the beam, okay, we consider the, for example, for the designing of interior beam, how much load we will consider. We consider the half slab load, okay, half slab load from this side and the half slab load from this side, and design this beam. Okay, for the designing of exterior beam, we take only the half load from this side. Okay, we take the half load only from this side. And if, for example, there is a for example cantilever portion is present, okay, for example, first of all, on this beam how much load will come? Lx by 2, Lx by 2 length, length of the slab will come, will contribute to the load to this beam. Okay, and if on the other side cantilever portion is present, then that will also include in the will include the then the load of the cantilever slab will also include in this exterior beam. Okay, so here is the formula for width of the slab supported by exterior beam. Okay, here this beam, the width of slab supported by this beam, if cantilever slab is present, then that is Lx by 2, that is the width, okay, will be supported by this beam, and if any cantilever portion is present. Similarly for interior beam, for this interior beam, okay, Lx by 2 from upper side, Lx by 2 from this side, so the total width of the slab supported by interior beam, that is Lx. So that's all for the one-way slab. So now I will discuss about the two-way slab. Okay, the two-way slab, by definition, if the longer dimension to shorter dimension is less than and equal to 2, then that slab is called two-way slab. Okay, so now let's see the two-way slab. Okay, here is the column arrangements. Okay, in the column arrangements, here is the beam running, this beam, this beam, this beam, this beam. Okay, this is the just the symbolic demonstration of the two-way slab load distribution. In the two-way slab load distribution, we mark the slab at 45-degree angle. Okay, here again in this slab, okay, here again 45-degree lines. Okay, at where the 45-degree lines intersect, we connect the lines. Okay, so now for this exterior short beam, this triangular load will come on this exterior short beam, and in this exterior long beam, this trapezoidal load will come on this beam. The slab load on this beam will come trapezoidal load. And this interior short beam, okay, this is long, short, okay, this triangular load will come from this side of the slab, and this triangular load will come from this side of the slab. Similarly, whole slab is distributed into the with the demonstration with symbols. Okay, this is the triangular load distribution and this is the trapezoidal load distribution. Okay, again you can see the nomenclature. This is the exterior long beam, this is the interior long beam. Okay, this is the interior short beam, this is also interior short beam, and this is the exterior short beam. Okay, this demonstrate this symbols you are already know. This is the longer dimension ly, this is the shorter dimension lx of the slab. Okay, now I will discuss how to take the load for the analysis of beam in the, and how to calculate the triangular area load and apply the load on the beam for the designing of beam. Okay, first of all, interior short beam, I will just select this panel. Okay, this total length is lx and the half length will be lx by 2. Here you will see that panel, interior short beam. Okay, total length was lx, the half length is lx by 2, lx by 2. Okay, the inclination where the slab is distributed, that is the 45-degree angle. Okay, so if I just highlight this portion, if this length is lx by 2, then due to 45-degree angle, this length will also be the lx by 2. Then to calculate this length, I will just use the Pythagoras theorem, lx by 2 whole square plus lx by 2 whole square and the under root comes over both items. These two lengths are same, so lx by 2 whole square will be cancelled out with the under root and only the under root 2 will left, so that the answer will come under root 2 into lx by 2. Okay, so if this dimension is under root 2 into lx by 2, then you can multiply this length multiply with this length, you will get the area of this this rectangular portion. Okay, this square portion by forming these two triangles. Okay, this length multiplied by this length, this will become lx by 2 again whole square, and this under root 2 multiply with under root 2, under root 2 will be cancelled out, so the answer will become 2 into lx square over 2 square. 2 will be cancelled out, answer will be lx square over 2. Okay, this is the total load will come. Okay, here is the total load, here is the lx square by 2, the load coming from these two triangles. Now this is triangular load, we have to convert this triangular load into equivalent UDL. Okay, for the simplification, this triangular load on both the sides is to be replaced by equivalent UDL. Okay, means now I will convert this means VDL load, okay, triangular load to UDL, which gives same moment as for the actual triangular load. Means we simplify into UDL load, but the result will be same, means we will get the same moment. Okay, as we get from the triangular load, we also get the same moment from the UDL load. Okay, how I will convert here? Equivalent here, first of all, that was the triangular load, now that is the equivalent UDL load. Okay, equivalent UDL load means now this load will transfer from this side on this short beam, and from this side this UDL load will transfer from this side. Previously that was triangular load. Okay, so how the area of this two triangles portion I have just shown, lx square by 2, so it is multiplied with 4 by 3. What is 4 by 3? It is a conversion factor to convert VDL load to UDL load. Factor of 4 by 3 convert this VDL load, weighting distributed load, to UDL. Okay, so just multiplied with 4 by 3. Okay, the answer is 2 by 3 Lx square. So now this equivalent UDL load is 2 by 3 Lx square. Okay, so if I just multiply with one side this dimension Lx, then I will get the other dimension due to the rectangular portion. Okay, equivalent width supported by interior beam. To get this width, I will divide this with this length, then I will get the other length. Same way here, 2 by 3 Lx square divided by Lx, I will get 2 by 3 Lx, this equivalent width. Okay, and if any for example, okay, here for the calculation of the UDL, if for the exterior short beam, you will just divide this area by 2. Okay, similarly the equivalent width, again the equivalent width of this interior short beam will be half of this exterior short beam. Okay, here equivalent width supported by interior short beam, that will be if area will be divided by Lx, will be this. Equivalent width supported by exterior short beam, okay, that will be the total length divided by 2. Okay, 2 will be cancelled out, so value will be Lx by 3. Okay, and sometimes if the any cantilever portion present on the exterior side, then you will also uh, take the width of that cantilever portion. So that's why here in the formula plus cantilever. Okay, so that's for the uh, interior short beam and exterior short beam. Now I will make the calculations for exterior long beam. Okay, here is a trapezoidal loading.